Welcome, ladies and gentlemen, to the E3 Essentials Revision Digital Technologies. That is the particular segment that this is going to be on. I understand that many of you are quite worried about your familiarity with digital technologies, and this new segment that I'm adding into the E3 revision, I hope will help you alleviate all of those doubts, all of those problems. You can move on forward with a good level of confidence that you are aware of all the digital technologies that the syllabus has prescribed for you. Let's take a look. Before we get started, I must remind you a few small suggestions. Please have a notebook and pen on the ready. Follow the slides and my explanations carefully. Make notes as you deem necessary. Do maintain a list of key topics that you feel you're weak at, so you can self-revise later or even bring it up in our live sessions. Maintain a list of key performance and management tools that can help modeling answers in the strategic case study exam. On that note, a quick reminder on the essentials of the essential core activities that have been assigned to you. A and B, of course, which belong to the enterprise strategy area. This A is basically developing business strategy, B is evaluating business ecosystem and business environment. And with respect to both, in fact, if you pay attention to the fourth one, recommend opportunity and threat responses, including digital. So digital is something that we continuously see. For example, in the core activity B, respond to ecosystem changes. And most of the changes that are currently active in the world with respect to ecosystem movements is all of them powered by digital. So having a strong sense of awareness with respect to digital is extremely critical, extremely important. How can we talk about digital without really talking about disruption? So digital disruption is very important and is sort of the entry point for us to understand various digital technologies, because what the technologies has done or have done is disrupt the environment. Traditional business models are being re-examined as use of technological advances enables organizations to challenge the status quo and create value in new ways. So value creation in innovative approaches, through innovative methods is what digital enables us to do. Key driver is disruptive technology. In fact, even with respect to how I present myself to you and how I communicate to you, there's a lot of disruptive technology that enables the entire process. Disruptive technology relates to instances where technology is used to fundamentally change and disrupt the existing business model within an industry. So we will come across, as we go along, we're going to come across many technologies that fundamentally change and disrupt the existing business model. In fact, if you just think back a while ago, the mobile phone revolution, look at the number of changes, number of disruptions the entire ecosystem related to smartphones has gone through. Example for disruption and disruptive technology a little closer to our area is fintech, financial technology. Now, fintech businesses exist which can provide investment advice, offer banking services, transfer money internationally, provide mortgages and loans, exchange currency, etc. All of them enabled by technology we generally refer to as fintech. In fact, even with respect to, for example, my payments, I've been using a secure SSL secure gateway, a payment gateway, which is basically product of fintech. These are typically big earners for financial institutions. Goldman Sachs estimates that upstarts could steal up to 4.7 trillion in annual revenue and 470 billion in profit from established financial services companies, which is happening all around, right? If you look at WorldPay, Stripe, some of the payment gateways I've been researching on recently, they are all PayPal. They are all just overtaking traditional business services and disrupting the entire ecosystem. Advantages that fintechs have. better use of data, providing better understanding of their customer, and giving customers a wide choice, a frictionless customer experience using elements such as smartphone apps to provide a broad and efficient range of services. Customer experience is key. More personalization of products or services to individual customers, and the lack of physical presence, which reduces overheads and operating costs drastically, and access to cheap capital to fund growth. Now, I think a recent boom that we see in terms of funding is crowdfunding, which has again been enabled by digital disruptive tech. In fact, crowdfunding and that sort of cheap funding push has further fueled the existence and entries of disruptive technology. Now, when we try to just look at this from a very wide and practical perspective, I thought it might be good to try and understand some of the key research institutions and various firms that have really deep dived into understanding digital disruption. And your Kaplan 2020 material references a very interesting report by Accenture, the research firm. Accenture's Tech Vision report extract for 2015, and the links will be made available to you, as you can see on the slide as well. Now, Accenture referred to it back in 2015 as the digital revolution, and they highlighted 5 key areas: Internet of Me, outcome economy, workforce reimagined, intelligent enterprise, and platform revolution. So every single element that you see here, for example, in terms of in 2 years behind, right, you see factors like seamless collaboration, data velocity, beyond the cloud, active defense, software defined networking, etc. So little by little, all of this fueled a complete harmonization through the global industry of how information moved, how people got things done, how collaboration happened, how communication, including person to person, but also data transmission happened. For example, Internet of Me goes very closely, you can read the report, goes very closely with Internet of Things. But what I wanted to point out was, look at the leap from 2015 Accenture has taken to 2020. This is the 2020 Tech Vision report extract, the snapshot of the summarization of the 5 tech trends they identified this year. The I in experience, AI and me, the dilemma of smart things, robots in the wild, and innovation DNA. These are very interesting and they go into very high level of detail, and in a sense, when you think about or when you read those details, when you think, okay, how many scientists are working on these various technologies, how many developers, software engineers are researching in these various kinds of areas, it's really just amazing to see how big the world is, and we're a small cog in that whole element, and behind the scenes of the technologies that we use, there's a lot of big things that are going on, and the futuristic perspective is even more revolutionary. I don't know if it's good or bad. I really don't. I don't know if the impact is going to be good, positive, negative, how the nature is going to get affected. These things I don't know, but there are big things happening behind the scenes. So you can carefully go through this, but furthermore, this is World Economic Forum's one of their key reports on digital transformation, and look at the number of industries they've identified in terms of enabling digital platforms and ecosystem. They say that under each of these industries, you can have and you can revolutionize and you can digitize the platform and the ecosystem. The website link will be provided. You can check out the website link and you can go into each of those industries and see what their pitch is in terms of digitization. So here we have automotive, aviation and travel, consumer, electricity, healthcare, logistics, media, mining and metals, oil and gas, professional services, telecommunication, digital consumption, digital enterprise, etc. and so forth. So that is another take. One of my most favorite X was issued by PwC called the Essential 8 Technologies, which goes very closely with the syllabus content we are about to discuss. These are the 8 key technologies that PwC identified. This is from a report from 2019, 18-19 calendar year report. Artificial intelligence, which we will talk about, augmented reality, blockchain, drones, Internet of Things, IoT, robotics, virtual reality, and 3D printing. Most of these, maybe except augmented reality, virtual reality, and drones, we talk about. In fact, AR, VR, and drones are now so prevalent that it would be also good for you to have a basic common general knowledge of these technologies as well, or the fact that we do have these technologies that are being harnessed effectively across a number of industries to enable those industries do better. That brings me to the technology segment itself within the syllabus. The first technology we are going to discuss is artificial intelligence, or commonly known as AI. Artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that work and react like human beings. So it's almost like human beings trying to create another human being, someone or something that can think and act and do things for itself or by itself. Some activities that computers with artificial intelligence are designed for. So we are at a very primitive stage at the moment. If the ultimate goal is to replicate a human being, voice recognition, planning, learning, and problem solving, AI brings many opportunities for finance professionals to improve their efficiency, provide more insight, and deliver more value to business. In the long term, AI brings opportunities for much more radical change as systems increasingly carry out decision-making tasks currently done by humans. So even if you look at the World Economic Forum's presentations in terms of the most useful skills in the world for any corporate player, corporate participant to have, most of those things have been slowly tending toward things that are non-automatable, things that only humans can do, like creativity. And another very popular and one of my favorites in that top 10 list is teaching. There is nothing like teaching or learning from a human being. So there are certain actions, but most of the tasks that or decisions that can be taken if you program a machine are slowly being automated. Examples in finance: coding accounting entries, proving fraud detection, predictive models to forecast revenues, etc. For example, as I was one project I remember with my association to Moody's Analytics was they came up with this automated system of populating financial models, which was quite remarkable because we used to take about 5 days sometimes when we have to populate financial models and derive certain numbers and share prices. So AI, when you teach an AI to do something, and if the AI actually performs it efficiently than a human, there's a lot of time saved, etc., etc. So it's not a bad thing. What powers AI, right? The science behind artificial intelligence is mostly, there are many sciences, but one of the most frequently known, well-known, commonly known, popular sciences is machine learning. So machine learning algorithms detect patterns and learn how to make predictions and recommendations by processing data and experiences rather than by explicit programming instruction. So the idea with machine learning is that they learn. Machine learning, they learn rather than programming. So if you take Visual Basic and if you write an Excel macro file, right, with a set of instructions, you've said what to do and it does those things that you've asked it to do for you. But machine learning is the code itself, or the algorithm itself is actively learning. I think one of the best examples we can uh, talk about in this sense is Google Translate. So all around the world, there are people who translate from English to Japanese, and there are people who translate Japanese to English. Now, with all of these entries, with each entry, the algorithm, the Google Translate algorithm, keeps learning from the Japanese who translates English to Japanese, and learns from the English who translates vice versa. There are three major types of machine learning. One is called supervised learning, the other is unsupervised, and the third is reinforcement. Now, the concepts are very simple. Don't overcomplicate it. It's just for you to have a basic understanding. So supervised learning is where an algorithm uses training data and feedback from humans to learn the relationships of given inputs to given outputs. So a human, think of it like this, a human is supervising. So in that sense, there is always a human who is overseeing the entire learning process. Not exactly programming, this is not purely coding, but the learning process is supervised by a human. There are many things that need that sort of active human supervision until the algorithm learns to the level it can sufficiently deliver. The second one, you can go through the example. Second one is unsupervised learning, where an algorithm interrogates input data without being given any explicit output variable. So in this case, the human doesn't really teach what the outcomes or outputs will be with respect to those inputs. What will happen is that the input and there is a certain interrogation that happens with respect to the input data, and learning is that interrogation itself. For example, the input data might be customer demographic data, but the algorithm itself explores and identifies patterns, unlike supervised learning, where we would say that these are the patterns we are looking for, can you please look for this? So that supervision element is missing here. Third is reinforcement learning. Well, I think in a sense, reward-based learning, even to humans, especially younger ones, we use this kind of learning. It's where an algorithm learns to perform a task by trying to maximize the rewards it receives for the actions it takes. So basically, we teach the algorithm to say, look, this is the reward we are looking for. And if you're getting more and more of this reward, when you do a certain thing, you're getting more and more, then continue doing that. A simple instruction. So if you let an algorithm handle your investment, and if you teach the algorithm to say, look, when you make a trade, the ROI is calculated in this way, and higher the ROI, the better it is for us. You teach the algorithm that. There you go. You're reinforcing the algorithm to learn continuously based on the reward maximization goal. This is again, like for example, there are movies that have been made about this kind of thing. There are good movies and there are bad movies. A movie that comes to my mind, so one is there is a Marvel movie called The Age of Ultron, where Ultron is a particular AI, and it takes from its creator, a certain reinforcement. Say, okay, this is the way I see the world, so I should pursue that. And the more closer I get to that point, the more I need to follow this, which can be very dangerous when you look at it from that theatrical perspective. And there are plenty of examples, I suppose. So those are the three major types of machine learning: supervised, unsupervised, and reinforcement learning. The second technology that we have is cloud and mobile computing. Cloud and mobile computing is computing based on the internet. It avoids the needs for software, applications, servers, and services stored on physical computers. Instead, stores these with cloud service providers who store these things on the internet and grant access to authorized users. So you already know, I mean, even for my work, I pretty much use only Google Drive, and I also use OneDrive, Microsoft's cloud and Google's cloud. So mobile computing, cloud computing enabled. And I have no server, I have no storage space, I have no storage rack with me. Everything Google takes care of for me. Benefits: storing and sharing data on demand, self-service, flexibility, collaboration, it's more competitive, easier scaling, reduced maintenance, backups are easy to get, they are indeed. There is disaster recovery, they have various, the host or the server provider, they have various security measures to recover from disaster and basically better security. Risks of cloud and mobile computing. So reliance on the service provider. So if Google goes dark, I'm done. You might suddenly not be able to access the content. So there is a risk, regulatory risk with respect to data transmission, data privacy, etc. There can be so many challenges, and because data privacy is not heavily regulated yet, we are experiencing a certain amount of freedom, something that you wouldn't see in the general society. But I think down the line, these restrictions and these regulations will be more stringent, more detailed, and address a lot of problems that we are facing currently. Unauthorized access of business and customer data, again something related to security. These are definitely risks. I mean, a simple password hack could steal your entire amount of data, and various, I mean, hackers have their own ways. They know coding, they know how to get into the back end, they know how to leave loopholes. So there is a certain amount of cyber risk exposure when you let another person handle your data. Now this is storage, especially with the cloud. Unlike maybe physically storing your data, for example, I have my portable hard disk here, and there are physical threats to it, but it is also safe from some of the on the internet cyber risks that can happen, unlike the cloud. A simple example of how cloud and mobile computing might be of use to finance professionals can be seen in the budgeting process. Any organization which has several different locations, like a MNC, has historically experienced difficulties and time delays in constructing budgets which require input from people in different places. So I mean, this shared working, shared or the collaborative process. There are Apple videos, there are Apple promotional videos. There is actually one that is one of my favorites, where a team of about 5 people are putting together a project, and all 5 are quarantined and in different places. They're using iCloud and the connectivity. There's a little bit of IoT mix in there, but the cloud is definitely being used to collaborate. And then in 5 locations, they collaborate beautifully, get the project done. The third technology that we are talking about is IoT, Internet of Things. The Internet of Things can be described as the interconnection via the Internet of computing devices embedded in everyday objects, enabling them to send and receive data. So, see, pay attention, the Internet of computing devices embedded in everyday objects. So basically, everyday objects are added the capability of acting and transmitting and communicating through the internet. So if you embed technology, internet connectivity to your watch, you embed connectivity to your switch, your lighting, there you go, you have IoT in place. This data can then be used for practical applications to the potential benefit of both individuals and businesses. However, there needs to be some strategic justification for exploiting the potential of IoT. Now, one thing you have to understand is that if you get all devices to talk to each other, communicate with each other, this is not going to be easy, and there has to be some sort of technology that enables, and one of the fundamental technologies is internet. and you have to have internet availability, and the availability of the internet shouldn't be slow either. It has to bear more capacity, because within the zone of 1 kilometer radius, if you have 1 million devices, and if all the 1 million devices are going to talk to each other, there's going to be a lot of data transmission happening. This is one reason why 5G mobile tech is being pushed so hard and being adopted, because that level of speed is necessary for IoT to properly function. How the Internet of Things work? So you can see a red, yellow, the green arrows, orange and blue. So the red indicates storage devices that will collect data for future use. Yellow is remote devices such as smartphones will control IoT. So these are the remote devices. These are the storage devices. The internet will provide the platform for the connectivity. So internet most probably powered through 5G. Router or gateway will allow the devices to connect via Wi-Fi. There has to be some sort of gateway. Either it could be virtual, it could be physical, that enables this. And thousands of devices will be connected to the internet and or each other. These are the various devices, the everyday devices in which you embed internet communication technology or capability. That is what IoT does. The next one, and a very popular one and heavily discussed one, very common one, very valid nowadays, is big data. Big data is a term for a collection of data which is so large that it becomes difficult to store and process using traditional databases and data processing applications. And big data also often includes more than simply financial information and can involve other organizational data, both internal, external, which is often unstructured. So there's structured data and unstructured data. And fairly obvious from the word itself. So unstructured data is basically where you don't have a set tabulation, set parameter to structure that data specifically. It's basically a whole lot of, it's a mixed bag of data. Examples of data that inputs into big data systems can include social network traffic, web server logs, traffic flow information. So these are all places where big data gets generated, right? Social network traffic, web server logs, traffic information, satellite imagery, streamed audio content, banking transactions, web page histories and content, government documentation, GPS tracking, telemetry from vehicles, and financial market data. The amount of data which businesses have to store and interrogate has increased at an exponential rate, requiring new tools and techniques to make the most of them. So it's a simple idea, right? If you remember back in 2010, what Facebook had, 1 million, no, definitely more than that, maybe about 500 million users. Now imagine the exponential growth of 500 million users back in around 2010, maybe a little past that, to today, where you have at least almost 3 billion active user accounts. Imagine the bulk of the data that is getting generated and created. Another good example is satellite imagery. So satellite imagery is where you're basically, for example, you have a view of Earth that records real time every second continuously, right, on the highest definition camera possible, highest definition view possible, because the image itself is so big you cannot really absorb the detail of it without having high definition. So the sizes of these images are not small. In every sense, the data is really big, which is characterized by 4 V's, which we call the features of big data. What are they? Volume, variety, velocity, and veracity. So volume refers to the significant amount of data, like we talked about. Variety is that there can be numerous sources generating numerous varieties or numerous types of data. analog, digital, Morse code, pictures, images, numbers, digits, hashtags, location information, latitude, longitude, all kinds of data, right? All kinds of information, right? Velocity is that data is likely to change on a regular basis and needs to be continually updated. So it's the pace. Velocity is the pace, the speed, the rate at which the data is being generated. And veracity is rather, now the first three are more of qualities, right, of big data, but veracity is more of a pledge and pleading for data to have that quality. Is you can have false data, big data, which is probably something that we've seen generated a lot and we are seeing generated a lot today. But that is why it is important that this information, that we build a system of big data in the world where information veracity is always maintained, or the truthfulness. It is vital that the organization gathers data that is accurate and factual. From that, we move on to the benefits of big data: driving innovation, gaining competitive advantage, and improving productivity. These are three biggest or three main benefits of big data. Problem considerations of big data, what are these? It is important to realize that just because you can measure something doesn't mean it should be. Heavy duty sentence. Just because you can measure something doesn't mean it must be or it should be. Has a sort of very philosophical take to it also, but it's quite true. You must be very careful. A simple example is privacy. So just because you have a technology that can connect all the webcams in the world, that can tap into all the webcams and record all that content that you see from those webcams, like this one here, will you do it? Do you think you should be doing it? Do you think anyone should be doing it? All of you know Edward Snowden's, the whistleblowing story with respect to the NSA of the United States, where there was a lot of buzz about people being spied on. And imagine if it was happening, I think it was, I hope they stopped. Imagine the amount of data and information they must have been collecting. Definitely big data. There is a risk that valuable time and money will be spent measuring relationships and information that has no value for the organization. So basically, time and effort being put into something that is non-value adding. The organization needs to consider how to keep its data secure from viruses and hackers. Indeed, does the organization actually own the data it has collected on individuals? And there may be legal and privacy issues if it holds large amounts of data on potential customers. So privacy is something that is being talked about a lot. These are the problem considerations of big data. On that note, we move on to the next technology we have to talk about: blockchain. What exactly is blockchain? Now, it's even when blockchain was starting to get a buzz, I was quite interested, and it took me a while to really understand what was going on. What are they trying to do? I mean, it wasn't, at least for me, it wasn't very simple to understand. But when you really think about it, when you pitch it in the right way, or when you approach it in the right way, you realize, okay, this is a public ledger, a public system. We'll see what it is. Blockchain has been described as a decentralized, distributed, and public digital ledger. Decentralized, distributed, and public digital ledger that is used to record transactions across many computers, so that the record cannot be altered retroactively without the alteration of all subsequent blocks and the consensus of the network. Alternatively, it has been defined by the Bank of England as a technology that allows people who do not know each other to trust a shared record of events. Okay, so right, I know. Let's look at it this way. If you buy something from me, say you bought something, right, from me. You bought this course, this particular SES coaching program. Now, what will happen is there are several parties, right? There's me, my payment gateway, my bank. Then, okay, your transaction happens through you, your bank, and yes, so there are basically about 5 parties involved here. And what they're saying is that one, this transaction, this entire transaction, the fact that I raised an invoice to you and the fact that you made a payment to me is going to be public, at least to the people who it should be public to. And every single party, all the 5 members of this entire transaction, we call it the chain, are equally responsible to maintaining the chain. So I cannot really change. I can't, let's say for example, I raise an invoice and then I want to change that invoice. I want to change the figure, or you get the invoice, but you make a payment, but now you want to get it refunded. Okay, now when that happens, you know how difficult the process is, right? And you know how much trouble you have to go through to enable this kind of situations, change invoices, to get a refund if there is a refund policy and if the situation allows that. But what happens with blockchain is that because it's a public ledger, there's a real-time sequence of requests going back and forth, and you can enable, or you can really get something done quite fast, quite publicly, and quite securely, because the chain is linked, and therefore none of the blocks will be able to change without the explicit acceptance and permission of each of the other members of the chain. So because of the public nature, that aspect is also taken care of. The fact that everybody knows about what is going on, therefore if something changes, everybody accepts it, or nothing would change if everybody doesn't accept it. That is the simple idea there. Look at it this way. The main benefit is that in the digital era, cybersecurity is a key risk with IT systems and internet, because traditional systems are closed, and they're closed. So very few people are privy to what is going on. So modifications can be carried out by just one party. If the system is hacked, there is little control over such modification to prevent it from happening. If a hacker gets one node, one point of entry out of the 5 participants, the hacker hacks one bank and the system is closed. Nobody else knows what is going on. Personal information is being stolen a lot. It's happening a lot these days. So blockchain can prevent it. This is an example of how a block works. If you take a close look at this, A wants to send money to B. Okay. This transaction is represented online as a block. The block is broadcast to every party in the network. Those in the network approve that the transaction is valid. You know, I can tell you, for example, to get certain things done here locally, with respect to, especially in terms of financial transactions, where there is taxation involved, where there is regulation involved, and where there are, most especially banks are involved, things take a long time, a very, very long time, right? Something that you would get done in a matter of 1 hour online through a proper large bank in the United States, it takes at least 14 days here sometimes, because the verifications and the number of scams that are happening, and the amount of hacking, and the amount of just unaware, you know, because people are not really aware of security, cyber security. So people get cheated a lot. So because of these things, our banks are quite vigilant. And I know this because over the few years I've worked very closely with my banks, and to get something done, especially being a small player, you know, a small businessman. For recognized players, I'm sure the things are very different, but for people like us, it isn't really easy, which wouldn't happen if we had blockchain. So all the parties in the network approve that the transaction is valid. Block then can be added to the chain, which provides an indelible and transparent record of transactions. The money finally moves from A to B. So this is how blockchain operates. This one transaction, and the transaction online is represented as a block, chain of blocks. Features, how it works, and the benefits. Just to summarize, the main benefit of blockchain is security. In a blockchain system, transactions are recorded by a number of participants using a network. The same records are maintained by a number of different parties. As a transaction is entered, it is recorded not just by two parties, but instead by all the parties. All of the records are in the blockchain are publicly available and distributed across everyone that is part of the network. When a transaction takes place, the details of that deal are recorded by everyone. The value, the time, the date, and the details of those parties involved. All of the ledgers that make up the blockchain are updated in the same way, and it takes the agreement of all participants in the chain. The process of verifying the transaction is carried out by computers. It is effectively the computers which make up the network that audit the transaction. If all the computers review and verify, the systems of all participants in the blockchain have updated the records. The computers work together to ensure that each transaction is valid before it is added to the blockchain. This decentralized network of computers ensures that a single system cannot add new blocks to the chain. When a new block is added, it is linked to the previous block using a cryptographic hash, a code generated from the contents of the previous block. This ensures that the chain is never broken and that each block is permanently recorded. It is this control aspect of blockchain which addresses the main concern of cybersecurity. If anyone should attempt to interfere with a transaction, it will be rejected by those network parties making up the blockchain, whose role it is to verify the transaction. So that's a simple but a quick flow of how a blockchain works. The next technology we will be looking at is data visualization. So I think most of you are quite familiar with how data visualization works. I mean, even on if you look at Excel or PowerPoint, if you have, for example, design, insert, you've got smart art. There are a lot of ways how you can visualize your data. Excel has its own way. Then you've got all the charts, line charts, pie charts, bar charts, area charts, stock graphs, surface graphs, radar, etc. This is all various data visualization techniques. Therefore, is very important. Data visualization is a general term that describes any attempt to take data and help people to understand it better by presenting it in a visual context. So making things easier for people to understand. That's the simple objective. So patterns, trends, correlations, other relationships that might otherwise not be noticed in a narrative type presentation can become clearer and more obvious when presented using some sort of data visualization software. So I'm sure you're quite familiar with data visualization software. These techniques help organizations to understand their data in better detail and therefore to exploit it better to achieve growth and flexibility. This will then lead to competitive advantage as the organization moves ahead. So on the left, what you can see is just a snap of just various types of data visualization, from map to bar charts to pie charts to cross sections, etc., etc. On the right, these are some of the most popular softwares, platforms we have for data visualization. So if you look at this Power BI, Microsoft's Power BI and Tableau, these are two softwares I have worked quite closely with and in detail. There are other softwares, especially Zoho's platform, analytics platform, IBM Watson. These are all quite popular. Fusion, etc. are all very popular softwares that you can download, of course with a subscription, to visually present large sets of data. There we go. You want to take a look at this. So that's a full view of how it looks. All right. The next type of technology is 3D printing. Now, for some reason, with Cima, this is something that gets talked about a lot. And one thing I want to assure you is that this is no big deal, and please don't fear it. 3D printing, also known as additive layer manufacturing, is a process whereby three-dimensional solid objects are created from digital files. Each item produced, created by laying down successive layers of material, each of which is a thinly sliced horizontal cross-section of the final object. And the end product is a gradual build by repeatedly adding these cross-sections. So you can just watch a YouTube video to see how a 3D printing machine works and how layer by layer they keep adding until your final build is present. Benefits: reduced waste, eliminates transport costs, less environmental impact in terms of travel distance mainly, shorter lead times, greater customization, increased profitability and social benefits. Problems: cost can be very expensive. Initial investments also can be very high. Quality concerns, lack of skills, legal concerns, environmental impact, and ethical concerns. Ego. So what I've done is I've just here I've given you the links are available. Please, you can take a look at it. So on the left, what you can see is these various types of 3D printing technologies: SL, PJ, BJ, LM, EBM, FDM, LSMJ, etc. So they have different ways of in terms of the raw material they use. So here parts are built through polymerization. Here parts are built through bonding agent, and parts are built through melting. Here you go: ceramic, metal, sand, plastic, wax. Polymerization uses plastic. Bonding agent uses ceramic. Melting uses a number of various raw material like ceramic, metal, plastic, and wax. In terms of, and the qualities are mentioned here for each of them: durability, surface finish, detail, and application. Higher, rougher, lower, and functional parts here: lower, smoother, higher, and prototyping on this end. And here you basically get a few examples of 3D printing machines: Overload Pro, Flux, UP+2, Delta Maker, and Replicator 5th Gen. So they all have various qualities, various capacities, various thresholds which are mentioned. Yeah, you can take a closer look and do some googling to get a view, and a couple of YouTube videos can be very helpful. I've watched about 3, especially in the printing process itself. Moving on to the next technology: process automation. So it's simple, right? As the phrase suggests, process automation, also known as robotic, digital, or business process automation, refers to the use of digital technology to perform a process or processes to accomplish a workflow or function. Or to put it another way, processes that used to be done manually become automated. Benefits: productivity, accuracy, consistency, audit trail, flexibility, staff retention, availability, and cost savings. So productivity, accuracy, consistency are all quite easy. Audit trail, where automation should result in a complete log, machine logs. Flexibility, because you can play around with all these machines that you use to automate. Staff retention is where if you have high staff turnover because the jobs aren't very attractive, because they've got a lot of repetition and that can wear a man out, that sort of jobs you can automate. I mean, you can do a fair share of automation through Microsoft Excel. right? You learn a few macros, you automate some of the basic repetitive processes, repetitive tasks, something I've personally been involved in heavily in my previous corporate work. And life becomes far easier and much easier, and you save a lot of time, and then the humans actually can put in their effort to do the human work. Availability, sure. Machines, end of the day. Cost savings. Challenges: lack of integration in IT systems. There can be a lot of integration problems, compatibility problems, hardware problems, software problems, etc. Lack of standardization, where processes are not high volume and not based on set rules, not repetitive, and when you need an element of human judgment. Reluctance to reduce headcount, natural consequence in many people's eyes that it leads to job losses. So this is something that people are afraid of, right? And anyway, business process automation, BPO, the common term. And the moment you throw around a phrase like that, we're going to get a BPO hired. Basically what a BPO is, at least the ones who really do the BPO work, they are enablers, and they install process automation software to your company, your particular task or team that particular activity is being carried out in, and they get those softwares to learn and do the work. So then the question comes as to, okay, then what are the people in the company going to do? Are they going to leave? Are they going to lose their jobs? So this initial fear is a bit of a challenge with respect to process automation. And in my experience, it doesn't really affect much negatively, because staff, humans can always be put. I'm not saying it's not happening, but in my experience, with respect to my association to process automation, it has always enabled humans to do better, more value-adding things and get out of the mundane, repetitive tasks. Cost: acquiring or developing the necessary software may be beyond the budget. Yes, BPO, especially BPO hiring, can be very costly. Initially, can be very costly, and their pitch, when you get a BPO to come and pitch to you, one of their pitches is how in the long term, not sometimes in the medium term, but how in the long term your costs you will get this much of benefits. And lack of skills, this may be within the business itself, so you really need the kind of expertise that you need. That's why BPOs are themselves a booming business. So don't mistake BPO saying you want a call operation in your company and you want other people from some other company to do the calling for you. No, talking about process automation itself, software based BPOs, for which you need a certain level of expertise. Here, for example, I've used a robotic process automation. So when you have the manual, expensive, error prone process, tens of thousands of life insurance policies in suspense, regulatory pressure, 30 plus individuals working, 3 to 4 weeks of training. But when you automate it through RPA, robots develop the RPA platform within 2 weeks, suspense remediation automated, executed by robots, skilled resource freed to work on higher value activities, human errors are eliminated mostly, 80% reduction in process cost, tremendous improvement in process quality, logging and auditability. And so this is one of McKinsey's pitches for process automation in terms of internet audit trails and internet record keeping and maintenance. So sorry, not internet, insurance. One snapshot for you to understand how robotic or RPA works. So these are the technologies that we had to discuss with respect to your syllabus prescription. Here you go, quick revision. We started by talking about this digital disruption, and then the technologies we closely looked at are 3D printing, data visualization, blockchain, big data, IoT, Internet of Things, process automation, cloud and mobile computing, and artificial intelligence. That is the end of the enterprise strategy segment on digital technologies. As you can see here, yes, indeed, do keep learning and enjoy the process. On that note, this segment is over, and I hope you have a thorough understanding of how or what digital technologies are available for you to harness, especially with respect to the modern world and the way we digitize things. Other than that, definitely utilize in your exam. So on that note, until I see you next, all the very best, stay safe, and cheers.